In this instructional video, I'll show you how to use what we know about nuclear decay processes, first-order rate equations, and half-lives in order to solve this problem. We're given an initial amount of francium-210 and an amount of time it takes to decay to a particular amount. And the question becomes, well, what is the half-life of francium-210? Well, we can use our rate law, because we have an amount at a particular time, and we have an initial amount. So if we use our rate law here, and I'm going to write it in the ratio format, this will allow us to find a value for the rate constant. And because this is a first order reaction, once we have the rate constant, then we'll be able to determine the half-life. So our final amount was 0.25 grams, and our initial amount was 1 gram. And this decay process took 5.2 minutes. So we can simplify this and divide, and what we find for K is that we have minus 1.39 for our natural log, divided by 5.2 minutes. Now I've taken the liberty of moving the negative, and so that's going to give us a value for our rate constant. This gives me a value of 0.267 in reciprocal minutes for the rate constant. And because this is a first order reaction, I know that my half-life is ln of 1/2 over negative k. So this means then that t1/2 is going to be minus 0.693 divided by negative 0.267, and our units end up being minutes. And so I have, for the value of the half-life, this is equal to 2.57 minutes. And so we've been able to determine a value of half-life based on decay processes and sufficient information to use the rate laws to determine the value of the half-life.